Hello everyone, welcome to the paper discussion of your MPL chemistry. And I'll be your host and those in this paper discussion, and you all call me AV. So let's not waste much time and start the session. So guys, in this paper, the first question that you attempted was this. So question number 51 talk about anomalous pair in Mendeleev periodic table is. Okay. By seeing all these options, I can directly mark option 2 as a right answer because tellurium and iodine. Okay, if I talk about their molecular weight, it is 128 and this is 127. But still, in Mendeleev periodic table, iodine was placed after tellurium, whereas Mendeleev periodic table was arranged in the increasing order of their atomic weight. According to that, iodine should be placed first and then tellurium, but it was vice versa. Tellurium was placed first, then iodine. Okay, and this ambiguity was removed. Okay, and this ambiguity was removed by atomic number, which says that it is 52 and the atomic number of iodine is 53. Okay, so please make a note of it, and yes, I will suggest you to please remember all this anomalous pair in the Mendeleev periodic table, and these are mostly a memory based questions, guys. These are mostly what memory based questions, so the more you remember, the more easily you can mark. Rest all goes according to the synchronization of modern as well as Mendeleev periodic table. So question number 51, the right answer will be option number 2. Okay, talking about question number 52, which of the following statement is not true? That means we have to identify a false statement. Please make a note of it, guys. It has to be a false statement about F block elements. So first, all actinides are radioactive. The statement is true, but the option is not true because we need a false statement. Elements with Z greater than 97, greater than 94 are synthetic. Answer is yes, they all are man-made, that is radioactive. The statement is true, but not the right answer. The general electronic configuration is N-2 F1 to 14, N-1 D 0 to 1, and NS2. Again, this general electronic configuration is right, but our option is not right because we need a false statement. Last, obviously this has to be the right answer, but let's see what is wrong in this statement. Cerium and lutetium atomic radius increases from Z equal to 58 to 71. Atomic radius increases. That is not correct, guys. That is not correct. Since F orbital is coming, they have a very poor shielding effect, and in spite of increasing, it should decrease. The right answer should be what? It should be decreases. And since it is a wrong statement, that means the right answer. Hence, question number 52, I'll go with option number 4. Okay. Talking about question number 53, the element with Z equal to 54 belongs to. I always solve such kind of a question. Either you can write the entire electronic configuration or you can do this thing. Okay, let's see. So helium atomic its atomic number is 2. Then comes neon, right? What will be its atomic number, guys? Okay, what will be its atomic number? Just add 8 into it, so it becomes 10. Okay, we just have add how much? 8 into it. Then comes argon. These are all magic numbers. Again you have to add how much? Again you have to add how much? 8. So it becomes 18. Okay. Then comes what? Krypton. Again how much you have to add? 8. 8. Now you have to add 18. That becomes what? 36. Okay. Then comes xenon. Again you have to add how much? 18. Right? Clear? That will be how much? If I'll add 18 into 44, oh, directly we'll get 44. Answer is directly getting 44. Z is equal to 44. That it clearly means what? It belongs to 18th group. No problem. Now suppose if Z was 50. Supposedly Z was 50. So what I must have considered over here? 54. 54 is which group? 54 is 18th group. Right? So accordingly 53 will be which group? 17. Then 52 will be which group? 16. And then 51 and then 50. So 17, 16, then 15 and then 14. So 14 should be the right answer. I normally go in this way. Okay, or the second option is you can write the entire electronic configuration and then you can get the answer. Okay, but yes, this is more feasible and more logical way to approach. Yes, and since by adding only I got 54, so and this is what? 54. Clear? Sure. So question number 53, Answer will be option number 3. 54. Helium is an S block element. Answer is wrong. This is a wrong statement. It is a P block element. Electronic configuration of helium is 1s2. That is right. So option 1 is statement 1 is incorrect and the statement 2 is right, and hence the option will be what? 54, option number 3. Okay. Talking about 55, the correct trend for atomic radius is illustrated. Since nothing is given, we'll go with their normal atomic radius. Okay. So it will be followed with what? Lithium is more than beryllium, which is more than boron, then carbon, then comes nitrogen, then comes oxygen, and then comes fluorine. Okay. Clear? So lithium, beryllium, boron. See, this is first of all decreasing, so not the right answer. Again, lithium, boron. It has to be beryllium, not the right answer. Lithium, beryllium, boron, carbon. Here it is showing beryllium, not the right answer, and hence I'll go with option number 4. So question number 55, option number 4 is the right answer. Okay, clear? Talking about question number 56. These are the elements: boron, oxygen, chlorine, sulfur, and silicon. How many of the above element cannot have covalency greater than 4? Greater than 4. Always remember, guys, second period element. Okay, second period element, the maximum covalency that it can show is 4. They cannot have covalency more than 4. Okay, so boron belongs to second period, oxygen belongs to second, whereas chlorine, sulfur, silicon belongs to third period. That means they can have extended covalency that is more than 4, but boron and oxygen cannot show more than 4. And hence, how many above elements? There are only 2. So right answer will be what? Option number 2. So question number 56, the right answer is option number 2. Okay. Coming up onto the statement, all the following processes are endothermic. That means what? Delta H has to be positive. That means what? Energy need to be supplied. Okay. So I hope you must have inculcated this thing just by reading the statement. M or X is not a noble gas. That hint is already given. Okay. All the processes are endothermic except. So M gas gets converted to M positive ion. It is an ionization enthalpy and it will be positive. So this is endothermic. X minus get converted to X minus 2. X is already a negative charge. One more electron has been pushed. Okay, negative basically repels. So what we have to do? We have to supply energy so that X minus will get converted to what? It will get converted to what? A X minus 2 gas. That means again it's an electron gain enthalpy, but it is a second electron gain enthalpy, and that is why it is positive. Talking about the third one, X gets converted to X minus gas. Here a neutral atom, in a neutral atom I am adding electron. That is what? Electron gain enthalpy. That's a pure definition of what? Electron gain enthalpy. So what is electron gain enthalpy? It is the amount of energy released when an electron is added into a gaseous, isolated gaseous atom. So this is the first electron gain enthalpy, and apart from noble gas, the first electron gain enthalpy will be always positive, will be always what? Negative, where heat is already released. So yes, I'll go with this particular option. Question number 57, the option that is right is option number 3. Okay. Talking about the last option, let us justify. M plus is getting converted to what? M2 plus. Again, it's an ionization enthalpy. Rather, it is a second ionization enthalpy, and hence it will be always what? Positive. That means energy need to be supplied. Okay. So question number 57, right answer is option number 3. 58. An element M shows a sudden jump. This word is important. In its fourth ionization potential. Shows a sudden jump in its fourth ionization potential. So can I say that the moment we remove fourth electron, it's the moment we have removed 3 electrons. Okay, it shows the sudden jump. So ionization energy 1 is greater than ionization energy 2. We know that, and it is greater than ionization energy 3. But ionization energy 4 is much greater than ionization energy 3. What has happened over here? Can I say till this particular point it has reached the noble gas configuration? Can I say it has reached noble gas configuration? And since it has reached noble gas configuration, and now if you're trying to remove an electron, the jump will be very high. That means more and more amount of energy will be supplied. Hence, can I say its valency is what? 3. Its valency will be what? 3, or rather plus 3, right? So formula of its sulfate. So M, whatever M is there, it is 3. Okay, or plus 3, and sulfate is what? 2 minus. So if I'll do a cross rule, so it will be M2 and SO4 thrice. So M2 SO4 thrice is the option number 1. That should be the right answer. So question number 58, I'll go with option number 1. 59. Which of the following trend is correct for their size of gaseous species is given? So I can see a negative, positive and neutral. And according to the atomic radii, it says that an anion, okay, an anion of the same element will have a more size than its neutral atom, and then its cation. So since iodine is given, so the order will be I minus, then comes its neutral atom, and then I cation, that iodine cation. So option over here will be what? Option number 3. So question number 59, again option goes to 3. Okay. 60. This is something that you have to remember. I always keep on saying, student, 2 oxides you should definitely remember. First one is neutral oxide. There are again something around 7, 8. And the second one is amphoteric oxide. There are total 7. So please remember this thing. If you remember this oxides, your life will be much more easy in this kind of examination or this kind of questions. As a matter of fact, I remember that beryllium oxide is an amphoteric oxide. So I can directly match option A to 3. And now let us see where are 3 options. A1, option number 1 gone. A3, this can be the answer. A3, this can be the answer. And option number 4 is A1 gone. SO3. SO3 is a non-metal. Non-metal oxide is always acidic. So B will be 4. So B4, B1, option 3 gone. So this is the right answer. That means question number 60, the right answer is 2. And suppose if you have not gone in that way, if you remember neutral oxide, NO is a neutral oxide. So see, C will be 1. C is 1 over here. See. So if you remember these oxides, they are very small in number. If you remember this oxide, then your life becomes much more easy. Metal is what? A metal is what? Basic oxide. And if you'll see option number 2 and 3, they both have same thing. Non-metal is acidic, whereas this there are some element which oxides are what? Neutral. So if you remember this neutral and amphoteric oxide, your life will become more easy. Okay. 61. The molar solubility of silver chromate. What is silver chromate? Silver chromate will be Ag2CrO4. Is S mole per liter the solubility product of silver chromate? So Ksp they are talking about. Ksp is equal to what, guys? X raised to X, then Y raised to Y, and then S X plus Y. In silver chromate, Ag2CrO4. Okay. So this is the concept. X is over here how much? 2. Y is how much? 1. So it is 2 raised to 2, 1 raised to 1, S raised to 2 plus 1. So that is equal to what? 4S cube will be the right answer. So option number 1 will be the right answer for question number 61. Okay. 62. NH4OH shows common ion effect. Which common ion effect with all the following except electrolytes. That means it should have NH4 plus ion and OH minus ion. HCl, HNCl. Over here we required NH4 and OH minus ion. Right answer is HCl. Why? Because it does not have any common ion. So it cannot show common ion effect. Whereas in the second option, see, OH minus is there. OH minus is over here as well. NH4 is there. NH4 is there. NH4 is there. NH4 is there. And HCl, since do not have common ion, it cannot show common ion effect. Hence the right option will be what? 62. Got it? 63. Which one of the following salt undergoes both cationic as well as anionic hydrolysis? Always remember, guys, cationic and anionic hydrolysis will be given by the salt of weak acid and weak base. Please remember this thing. Okay. It will be given by weak acid or a weak base. Okay, salt of weak acid and a weak base. So salt of a weak acid and weak base. NH4Cl. It is a salt of weak base, strong acid. Okay. It is a salt of what? Weak base and strong acid. Clear? CH3COO, potassium acetate. Again, it is a salt of weak acid, strong base. So this is not the right answer. NaNO3, it is a salt of strong acid, strong base. Strong acid is what? HNO3. Okay, and weak strong base is what? NaOH. So it is strong acid, strong base. Whereas the last one, it is a salt of weak acid and weak base. So according to me, the right answer should be 63, option number 4. Got it? Next. The aqueous solution with least pH among the following, that means highest acidity. NH4Br is a salt, NaF is a salt, K2SO4 is a salt, whereas HI is a strong acid. Whereas HI is what? It is a strong acid. And since it is a strong acid, its pH will be least. Whereas rest all are what? They all are what? Salt. So this should not be the right answer. This should not be the right answer. This should not be the right answer. The right answer should be option number 4. So 64, I'll go with option number 4. Got it? 65. The Ka of acetic acid is this. Buffer capacity of CH3COH, that is basically a buffer solution, is maximum at pH of. Okay, so see, buffer is maximum, buffer capacity is maximum when pH is equal to pKa. Buffer capacity is maximum when pH is equal to what? pK. What is pK? Negative log of Ka. And what is negative log of Ka? What is log Ka given as 2 into 10 raised to minus 5. If you solve this thing, if I just keep negative outside, log of 2 plus log of 10 raised to minus 5. This is log of A raised to B. So it goes what? Negative log of 2 plus, sorry, this will not be plus, this minus 5, this minus 5 will come into what? Multiplication, and hence minus, wait, this minus 5 will come into multiplication. So it is minus 5 log of 10. Right? We know that log 10 is equal to 1. So what is the final equation? Now if I bring this minus inside, so can I say it is 5 minus log of 2? Okay, log of 2 is something around 0.3. This is what my knowledge serves me. And second thing, 5 minus log of any value is maximum 0.9. So it will be, and since it is a log 2, log of, I am talking about log of 10, 90, 99, I am talking about it is somewhat 0.9. So log of 2 will be somewhat 0.2, 0.3 onwards. Any which ways, the answer should be less than 5. 5 minus log 2, it should be what? Less than 5. So less than 5 is which answer? 65 to, that is 4.7. I'll go with 4.7. If you solve this thing, you'll get 4.7. Okay, clear? Sure. Now 66. At 298 Kelvin, the mixture of this and this, okay, contains mixture of this, that is NH4OH, and 100 ml of 0.1 molar NH4Cl. The pH of the mixture is, and the Kb value. So first of all, what they are doing is they are this NH4OH and NH4Cl, it's an alkaline hydrolysis. Okay, and whenever it's an alkaline hydrolysis and pH, so yeah, so first of all, it's about basic in nature. Okay, NH4OH and NH4Cl. So first of all, it is what? Basic in nature, and the solution is what? Basic. So we'll go with pOH value. Okay, so this is a basic buffer, right? How it is an basic buffer? It is an NH4OH in the presence of its salt. So basic buffer is equal to what? pKb. Basic buffer is equal to what? pKb plus log of concentration of salt divided by concentration of a base. Right? Clear? Now, since the molarity is given and its n factor is 1 or valency factor is 1, here also n factor or valency factor is 1. So I can say that my normality is equal to what? Molarity. Since n factor is 1, the normality is equal to what? Molarity. So with this thing, if I try to solve this question, so pOH, pKb is what? Negative log Kb plus log of salt, concentration of salt. So concentration of salt is nothing but volume into times number of moles. So can I say concentration? Okay, concentration will be what? Volume of solution, volume of salt solution divided by the normality of the salt solution, whole divided by volume of base multiplied by normality of base. That is equal to negative What is Kb equal to? Kb is equal to 10 raised to minus 5. Okay. Plus log of volume of solution of salt. Okay. So salt is how much volume? 10 ml. Multiply by what is the normality? 0.1, because molarity and normality is equal to 1. Whole divided by what is the volume of base? It is 100. Multiply by what is the molarity? Normality 0.01. So can I cancel this thing out? Because 10 into 0.1 is 1. 100 into 0.01 is what? 1. And that is equal to what? Log of 1. And log of 1 is equal to 0. And hence this will be what? 5 log 10, and log 10 is equal to what? 1. So that is equal to 5. So we get POH is equal to what? 5. Then what will be pH? Can I say pH will be what? 14 minus POH. That is equal to what? 14 minus 5. That is equal to what? 9. So according to me, the right answer should be 9. Let's see. Yes, the right answer is what? 9. Okay, so question number 66, the right answer is 9. 67. pH of 0.01 molar weak monoprotic acid is. So we need to calculate the pH, and the concentration is given by, since Ka is given, in terms of Ka, the concentration is given by Ka times C. What is Ka value? 4 into 10 raised to minus 4. So 4 into 10 raised to minus 4 into concentration is how much? 0.01. That is equal to how much? Can I say it is 4 into 10 raised to minus 2? Into 10 raised to minus 4 into 10 raised to minus 2. That is 10 raised to minus 6. So the root of what? 4 into 10 raised to minus 6. That is equal to what? 2 into 10 raised to minus 3. This is concentration of H plus ion. What will be pH is equal to? pH is equal to negative log of 2 into 10 raised to minus 3. That will be equal to what? 3 minus log 2. And 3 minus log 2 will be a log value less than 3. More than 3, more than 3, more than 3. So they are not the right answer, not the right answer, not the right answer. The only place where I can say it's a right answer is 2.669. Let's see. So option 67, option number 3 is the right answer. Okay. 68. The pH of this thing is, so H2SO4. We know that H2SO4 will dissociate as what? 2H plus ion, concentration, and SO4 2 minus ion. Okay, if this is 0.05 molar, so this will be what? Twice into 0.05 molar, because 1 mole of H2SO4 will give you what? 2 moles of H plus ion. So this is twice. Okay, and what will be the concentration of H plus ion from here? Can I say it is 2 into 0.05? That is equal to what? 0.1 concentration of H plus. That means negative log to the concentration of H plus is equal to what? If I take negative log, it is negative log to 10 raised to minus 1, because 0.1 is what? 10 raised to minus 1. So can I say pH is equal to 1? So yes, pH is equal to 1. According to me, question number 68, the right option has to be 4. Okay, sorry, right option has to be 4, where pH is equal to what? 1. Clear? Sure. Perfect. 69. At 298 Kelvin, equal volumes, please note this, equal volumes of two solutions, pH is equal to 9 and pH is equal to 12. They both are what? Alkaline in nature. Since pH is more than 7, they both are what? Alkaline in nature, are mixed. The resultant mixture will be. So always remember, if equal volume of two alkaline solutions are mixed, then the resultant pH will be equal to the higher pH, will be equal to the what? Higher pH minus 0.3. Minus 0.3. So what is the highest pH over here? 12 minus 0.3. That is equal to 11.7 should be the right answer. This is one way of doing it. This is what one way of doing it. If you remember this formula, it's okay. If not, another way you can do it, what? You take pH, because it is given pH and the solution is alkaline. So what you'll be getting is the concentration of OH minus ion. What will be POH over here? Can I say it is 5? What will be POH over here? Can I say it is 3? Right? So concentration, let me start from here. The first concentration of OH minus ion with the pH 5, can I say it is 10 raised to minus 5? Whereas the concentration of the second pH is 10 raised to minus 3, right? From here, can I say the number of moles? Number of moles, since concentration is equal to what? Concentration is equal to what? Number of moles by volume. So number of moles of the first pH will be 10 raised to minus 5 times V, whereas N2 will be equal to what? 10 raised to minus 3 times V. Now what is the total concentration? Total concentration or net concentration, can I say it will be N1 plus N2 by total volume. So what is N1? 10 raised to minus 5 times V plus 10 raised to minus 3 times V whole divided by V1 plus V2, that is twice of V. V1 is equal to what? V. V2 is equal to what? V. So V plus V is what? Twice of V. Now what I am taking is I am taking out 10 raised to minus 3V outside. Okay, and this is 2V. What will be remained over here? Can I say it will be, if I take 10 raised to minus 3, so I will get 10 raised to minus 2 plus 1. This V and V get cancelled, right? So can I have an equation that is 10 raised to minus 3 by 2, okay, into 1 plus 0.01, that is 10 raised to minus 2. Now 1 by 2 is how much? 0.5 into 10 raised to minus 3, right? And that is 1.01. That is equal to what? 5 into 10 raised to minus 4, 1.01, right? And that will be equal to what? 5 into 10 raised to minus 4 approximately. If you multiply inside, you will get 5 into 10 raised to minus 4 approximately. This is the net concentration of OH minus ion. So if I try to calculate POH, POH will be equal to what? Negative log of concentration of OH minus ion. That is equal to what? Negative log of 5 into 10 raised to minus 4. And that will be giving you what? 4 minus log of 5. 4 minus log of 5 is less than 3. Less than 4, right? The value will be what? Less than 4. Getting the point? So if you do this calculation, the value will be less than 4. Less than 4, that is around 3 point something, and 3 point something, that will be what? POH. So your POH is equal to what? Less than 4, right? So what will be pH equal to? What will be pH is equal to? Can I say 14 minus something less than 4, right? Something less than 4, and can I say that the answer will be something like this, 11.7 or something, right? So that is the right answer. Okay, so for question number 69, the option 3 is the right answer. Got it? Clear? So yes, the smallest way is to remember this. The smallest way is to remember this. Clear? Or this is the way that you can calculate if you don't remember the formula. Okay. 73. Okay, no, question number 70. NH3 plus HCl gives you ammonium plus chloride ion. It's a neutralization reaction according to. Now if you'll see NH4 plus. So can I say that here NH3 has accepted this H plus. So can I say this is a proton donor, whereas here it is proton acceptor. And since the entire discussion is related to proton, the only theory that talks about proton is Bronsted-Lowry theory or Lowry-Bronsted theory. So 70, option number 2 is the right answer. 71. At 298 Kelvin, the pH is 10 raised to minus 8 molar HCl. First of all, it is HCl, so it's obviously pH cannot. Okay, we need to calculate pH of 10 raised to minus 8 molar HCl. Obviously, since it is an acid, its pH will not be more than 7. Even if you apply that logic, the answer that comes out to be the possible answer that will come out to be for 2 or 4. So this option is gone and this option is gone. Okay, now let us see. So pH over here is 10 raised to minus 8. Hence, I can consider concentration of H plus ion is 10 raised to minus 8. Okay, not pH, sorry, concentration of H plus ion is 10 raised to minus 8 at 298 Kelvin. Right, and we also know that at 298 Kelvin itself, Kw is equal to 10 raised to minus 14. Kw is equal to 10 raised to minus 14, and at 298 Kelvin only we also know that concentration of H plus ion is equal to the concentration of OH minus ion, that is equal to what? 10 raised to minus 7. In this case, can I say that the concentration of H plus ion for HCl is less than the concentration of H plus ion for H2O? Can I say this thing? And since the concentration is less, that means the concentration of H2O should be considered. Since the concentration of H plus ion for HCl is less than the concentration of H2O, that means it needs to be considered. So the net concentration will be what? 10 raised to minus 7 plus 10 raised to minus 8. Yes or no? So here if I'll take out 10 raised to minus 7, so it will be 1 plus 0.1, that is equal to what? 1.1 into 10 raised to minus 7. So this is what? Concentration of H plus ion, right? Got it. So concentration of H plus ion is 1. So can I say now pH will be equal to what? Negative log of concentration of H plus ion, that is equal to what? Negative log of 1.1 into 10 raised to minus 7, that is equal to what? 7 minus log of 1.1. 7 minus log of 1.1 will be the value something less than 7. Something less than what? 7. And something less than 7 is option number 2. So question number 71, option number 2 is the right answer. Okay. 72. Which among the following is a Lewis acid? Which among the following is a Lewis acid? And what is Lewis acid? The one which accepts electron. Okay, the one which accepts electron. So electron acceptor is what? Option number 3. BF3 is the one that accepts electron. So 72, option number 3 is the right answer. Okay. 73. Which one of the following species cannot have a conjugate base? Cannot have a conjugate base, that means you cannot remove H plus ion, and that H should be bonded to what? Cannot remove H plus ion, that simply means, can I say that hydrogen is not bonded to electronegative atom, right? If you see here, hydrogen is bonded to electronegative atom, HCO3 minus. So can I say its structure will be something like this? Right. So here we have an H plus and hence it can be removed. So this should not be the answer. NH2, we can directly say that hydrogen is bonded to nitrogen. So we have a proton that can be removed. Here H can directly be removed. But over here H2PO2, if you remember, this is an what? Hypophosphorus acid. Its structure will be like H, P double bond, okay, and then hydrogen, and then O minus. Okay, these two are not acid. This hydrogen cannot be removed easily, and since it cannot be removed easily, it cannot form what? Conjugate base. Hence, according to me, the right answer has to be question number for question number 73, the right option has to be option number 1. Okay, clear. 74. Which of the following thermodynamic property is a path function? Heat and work both are path function. Without any doubt, mark option number 1. Okay. Coffee is closed. Coffee in a closed insulated vessel is an isolated system. No need to think on it. 75, option number 2, without any thinking. Intensive property is density. No problem in that. Enthalpy, mass and entropy depends upon what? The substance, amount of the substance. Okay, so answer is 3. And intensity is again, it's a ratio of two extensive property. Okay, density is equal to mass by volume. So 76, 3. Again, I'll just give you one suggestion over here for intensive and extensive property. Please try to remember intensive and extensive property by heart. That will make your life more easy. Okay. 76. Which one of the following species is amphiprotic? Okay. Amphiprotic basically means what? It can accept and donate proton. Amphiprotic means what? It can accept and donate proton. Okay. So H3O plus. I'll remove this thing from my answer because now it cannot accept one more H plus. That is already been done. It cannot accept. Rather, it can donate one H plus ion, but it cannot accept one H plus ion. Okay, clear. Talking about this H3PO3. So if I'll draw its structure H3PO3. Okay, so see. Minus, this is H3PO3 minus 2 structure. It can definitely accept H plus. It can accept H plus, but it cannot donate this H plus. This is not available. So can I say this is also gone? This should not be the answer. Acetate ion, H, C, double bond O, O minus. Okay, it can accept one H plus, but it cannot give this thing as an H plus because it is not acidic. Talking about bicarbonate ion, C, double bond O, O minus and OH. It can accept one H plus ion, and as a matter of fact it can donate one H plus ion as well. So it can get converted to CO3 2 minus, or it can get converted to H2CO3. That means it can accept and donate proton. So 2 3 are out of scope, 2 3 4 are out of scope, and the right option has to be 77 1. Okay. 78. At 369 Kelvin, pH of pure water will be. What we know is at 298 Kelvin, Kw is 10 raised to minus 14. At 369 Kelvin, that means the temperature has increased, and that's why the Kw value will increase, and hence Kw can be between 10 raised to minus 13 or 10 raised to minus 12 or 10 raised to minus 11, go on, because the value has increased. Kw will increase, right? So with this notion, can I say that now Kw, okay, that is concentration of OH, that is concentration of H plus, okay, and the concentration of OH minus ion would be equal to either 13 or 12 or 11 or 10. In whatsoever cases, can I say that the concentration of H plus will be less than 10 raised to minus 7? And since the concentration of H plus is less than 10 raised to minus 7, its pH will be always what? It will be less than 10 raised to minus 7. So right answer should be what? The pH will be less than 10 raised to minus 7. So question number 78, the right option is less than 10 raised to less than 7. pH will be what? Less than 7. Okay, clear? Now, hyperconjugation is not exhibited by. What is hyperconjugation? Hyperconjugation is nothing but an sp3 carbon. Okay, this is an sp3 carbon is bonded to an sp2 hybridized carbon, which either have a carbocation or a free radical or a vacant p orbital. Okay, so this has to be what? This can be a double bond, okay, or it can be a carbocation, okay, or it can be a free radical. Either it has to be a vacant p orbital or what? It has a pi orbital bonded or pi bonded electrons. Okay, and this sp3 hybridized orbital should have at least one alpha hydrogen. Since this is a main center and this is what? An alpha carbon, so this is known as what? Alpha hydrogen. So when it has alpha hydrogen, then and only then it shows what? Hyperconjugation. So this is a main group. This is an alpha carbon, it has alpha hydrogen, so it shows hyperconjugation. That means not the right answer. We just have double bond, there is no alpha carbon, and there is no alpha carbon, that means there is no alpha hydrogen, and hence no alpha hydrogen means what? No hyperconjugation. This will be the right answer. Question number 79, option number 2 is the right answer. Over here also see, this is a main group, this is an alpha carbon, so shows alpha hydrogen. Main group, alpha carbon, that means it can show alpha hyperconjugation. Hence the right answer is what? Option number 2. 80. Hyperconjugation involves sigma and pi electron both. Remember, it involves sigma and pi electrons both. Okay, so 80 is option 3. 81. The following species does not exhibit hyperconjugation. We just said carbocation is there and there is an alpha carbon, so it will exhibit. Carbanion does not show. Just see this one, guys. Just see this one. We have just discussed over here. Either it has to be a pi bond or a carbocation or a free radical. Okay, in carbanion, there is no vacant p orbital. Okay, I can say, right, no vacant p orbital. And since there is no vacant p orbital, there is no hyperconjugation, and hence the right answer will be option number 2. 81 is option number 2. 82. Regarding this, the incorrect statement. It is aromatic. Yes, it is aromatic. It follows Huckel's rule. It is planar. It is cyclic. It is planar, and then it is conjugated as well and follows Huckel's rule as well. So it is aromatic. It is non-planar. This is not the right answer, guys. This is true statement, but it is not the right answer. It is non-planar, it is wrong, but hence the right option. The compound is what? Aromatic, and had to be an aromatic, it has to be a planar. Option number 2 talks about is non-planar. What we need to know is incorrect. The statement is incorrect, and hence the right answer is this. But the statement is incorrect. Please make a note of it. Now, which of the following species is non-aromatic? Non-aromatic. The first thing you just need to identify, is there any particular carbon which is sp3 hybridized? That means the first thing is cyclic. You need to check cyclic. Planar. How you'll come to know whether it is planar or not? To find whether there is a carbocation which is not in conjugation, or there is some sp3 carbon. This carbanion which is not in conjugation, or sp3 carbon. If either one is present, that means what? It has to be a non-planar. Carbanion conjugated with double bond, that means it is what? Planar. See this, sp3, sp3. There are two sp3 carbon atom over here, and since it is sp3 carbon atom over here, it has to be a non-planar structure. It has to be what? A non-planar structure, and hence 83 option number 2 is the right answer. 83 option number 2 is the right answer. 84. Which one of the following obeys Huckel's rule but it is non-aromatic? Obeys Huckel's rule, and Huckel's rule we know that how many pi electrons should be there? 4n plus 2 pi electron. That values goes to 2, 6, 10, 14, 18 and so on. Okay, so 2, 4, 6 electron, 2, 4 electron, this is 8 electron, and this is 10 electron. So 10 electron follows Huckel's rule but it is aromatic. 8 electron does not follow Huckel's rule, right? 4 electron does not follow Huckel's rule. 6 electron follows Huckel's rule, but see, sp3. That means it is non-planar, hence it is non-aromatic. Hence option number 1 will be the right answer. Option number 1 is the right answer. 85. Aromatic species need not exhibit resonance. Absolutely wrong answer. It has to be a resonance. Every species which exhibit resonance is aromatic. Absolutely wrong. Resonance is a condition for definitely to show aromaticity, but that doesn't mean each and every resonating compound should be aromatic. For an example, cyclobutadiene. If you see this compound, that is highly, it shows proper resonance, but this compound does not exist because it is what? Anti-aromatic. So resonance does not mean aromaticity. But yes, resonance is a particular condition for aromaticity. Hence both the options are wrong. I'll go with option number 4. Both statement 1 and 2 are what? Incorrect. Okay, clear. 86. Correct statement among the following are: non-metals will have covalent radius, true, and van der Waals radius, true. So this is true. Metals will have covalent and crystal radius, true. Noble gas will have covalent, wrong. And van der Waals, yes, it does not have covalent because they are monoatomic, and in monoatomic there is no covalency. So according to me, A and B is right. So I'll go with option number 1. Okay, 86 option number 1 is right. Okay, 87. Incorrect trend among the following about the first ionization enthalpy. So if I want to know the ionization enthalpy trend, okay, from maximum to minimum, we know that the first one comes for the second period. They all belong to what? Second period. Neon, then comes fluorine, okay, then comes nitrogen, then comes oxygen, then comes carbon, then comes beryllium, then comes boron, and the least one is lithium. Here, due to half-fill stability, right, and over here there is an ambiguity because here you have to remove electron from p orbital, here you have to remove electron from s orbital, and removing electron from s orbital is a bit difficult as compared to p orbital. That's why it's what ionization enthalpy increases. So let's see. Beryllium is less than boron. That is the only wrong. Nitrogen is more than carbon. Yes, nitrogen is more than carbon. Oxygen is less than oxygen is less than fluorine. Yes. Carbon is more than boron. Yes. The only ambiguity or the only incorrect trend is what? The option number 1. So 87, 1 is the right answer. 88. The halogen with highest magnitude of electron gain enthalpy is chlorine. Please remember, fact based. Chlorine has vacant d orbital. Although fluorine is highly electronegative, it can pull the electron toward itself, but it does not have vacant d orbitals. Whereas chlorine is also electronegative, it can pull the electron toward itself, not as electronegative as fluorine, but yes, since it has a vacant d orbital, this is very important. It has a what? Vacant d orbital. It can accommodate electron very easily as compared to fluorine. So this is the order. Please remember the order: chlorine, fluorine, bromine, iodine. This is electron gain enthalpy order. Okay, this is what electron gain enthalpy order. Electronegativity order, there is no doubt. This is electronegativity order. Fluorine, chlorine, bromine and iodine. This is electron negativity order. Okay, please make a note of it. Acha, the next one is that thing only. Which of the following element has higher value of electronegativity on Pauling scale? So if I am not mistaken, fluorine is fluorine is given as 4. Then after fluorine, what I remember is oxygen is 3.5. Then comes nitrogen and chlorine. That is around how much? 3, if I am not mistaken. Okay, so this has to be the order. Let me see if I can get something out of it. The least, what they have asked is which of the following element has higher value. So fluorine is not there. Then oxygen is there. Yes, oxygen is there. Bromine is around 2.8 around. If my knowledge serves me right, bromine is around 2.8. Just make a note of it. But I am certainly sure that after fluorine, what comes is oxygen. Okay, clear? So option number 4 is the right answer. So after fluorine, the next electronegative atom is what? Oxygen. 89. Option number 4 is the right answer. The maximum valency of phosphorus with respect to hydrogen. So with respect to hydrogen, it forms phosphine, that is pH3. pH5 does not exist. And with respect to oxygen, it forms P2O5, right? P2O5 or P4O10. So maximum valency, they are talking about sum of X and Y. So here it is 3, here it is 5. So 5 plus 3 is 8. So question number 90, option number 4 is the right answer. Okay. 91. The solubility of AgCl is least. So remember this thing, guys. Solubility is inversely proportional to common ion concentration. Okay, common ion concentration. And Cl. So common ion is what? Chlorine. So concentration of chlorine over here is equal to what? 0.1. And how many chlorine it will give? Only 1. So it is 0.1. Here there is no common ion. No common ion. So we cannot discuss for this thing. Over here again, chlorine is this 0.15 into 1, that is equal to 1.5. Oh, sorry, not 1.5. It is 0.15. CaCl2, it will give 2 moles of Cl minus ion. So here Cl minus ion will be equal to what? 0.1 into 2, that is equal to what? 0.2. So this has maximum common ion concentration and hence less solubility. And hence what? Less solubility. Right? So solubility is least. They have asked what for least. Hence the right answer will be what? 91, option number 4. Okay. 92. The solubility product of a sparingly soluble salt of this is, so KSP, we know that it is x raised to x, y raised to y, s raised to x plus y, is given as what? 1.08 into 10 raised to minus 5. This is the option. 2 raised to 2, x is what? Here it is x, here it is y. So 2 raised to 2, 3 raised to 3, s raised to 2 plus 3 is what? 5, equal to what? 1.08 into 10 raised to minus 5. So 2 raised to 2 is 4, and this is 27, s raised to 5, that is equal to 1.08 into 10 raised to minus 5. So 7 4s are 28, 4 2s are 8, 9 10, that is 108, s raised to 5, this is 1.08 into 10 raised to minus 5. Okay, if I'll take the fifth root of it, okay, or let us just go in this way, s raised to 5 is equal to 1.08 whole divided by this into 10 raised to minus 5, right? So s raised to 5, This is how much? 10 raised to minus 108 into 10 raised to minus 2 into 10 raised to minus 5 whole divided by 108. So this get cancelled, right? Clear? Now fifth root. Let us take the fifth root, s raised to 5. So if I'll take a fifth root, okay, that is 10 raised to minus 5 into 10 raised to minus 2. Clear? Sure. Then what will be the answer? If you solve this thing, the answer fifth root, this will come out 10 raised to minus 5, 10 raised to minus 7. Okay, the answer will be coming around what? 10 raised to minus 1, right? It will be coming around what? 10 raised to minus 1, and this is what? 10 raised to minus 1 is approximately equal to what? 0.1 molar, right? So do we have 0.1 molar? Yes, we have 0.1 molar. That is 92. Option number 3 is the right answer. Okay, clear? Oh wait, how it can be a right answer? Wait, this is 1.08 into 10 raised to minus 3, guys. Please, it is not 10 raised to minus 5. It is 10 raised to minus 3. I guess I have done some mistaken over here. There is something mistaken over here. Let me cross check the answer once again. Okay. Yeah. So now 10 raised to minus 3, 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 10 raised to minus 3. So it will be 108 into 10 raised to minus 2 into 10 raised to minus 3. I have converted this 1.08 into 10 raised to minus 2. Okay, whole divided by 108. So this 108 get cancelled, and the value that comes out to be 10 raised to minus 5, s raised to 5. So s is equal to what? Fifth root. Okay, fifth root of what? 10 raised to minus 5, right? That is equal to what? 10 raised to minus 1. And yes, again coming out to be the same thing. 10 raised to minus 1 is what? 0.1 molar. Hence 92. Option number 3 is right. Okay. pH of an aqueous CH3COOH does not depend upon the concentration of the salt. True. Why I am saying true? Because this is a salt of weak acid and weak base. So pH for weak acid and weak base is equal to what? 7 plus half pKa minus half pKb. So it does not depend upon the concentration. So that statement is true. H2SO4 can form normal salt as well as acidic salt. Yes, normal salt is Na2SO4. Acidic salt will be, if I am not mistaken, NaHSO4. So the both statements are what? Right, and hence option number 1 will be the right answer. 93. 94. Which one of the following mixture acts like a buffer? Buffer is what? It is a salt. Buffer is what? A solution of weak acid plus the salt of weak acid and strong base plus the salt of what? Weak acid and the strong base. So NaCl and HCl. First of all, HCl itself is a strong acid, not the right answer. CH3COH is a weak acid. Okay, CH3COH is a weak acid, whereas it is a salt of weak acid and strong base. And this is the most famous example that people discuss while discussing buffer solution. So you should remember this thing. Option number 94, question number 94, option 2 should be the right answer. Let us prove the another one wrong. See, again, it is a strong base. It cannot be a buffer. What requires a weak acid or weak base plus salt of weak base and strong acid. But yes, it has to be a weak one. Okay. Again, HCO, okay, KCl. KCl is a salt. This is also a salt, so that cannot form. So 3 options are not the right one. So 94, option number 2 is right. 95. The strongest conjugate base among the following is. To know the strongest base, let us form it. Do we not conjugate base? Let us form its acid. So suppose all these are conjugate base, we need to form its acid. So HCl, CH3, COOH, then HCN, and then HI. If I want to write the acidic strength order, we know that HI is the strong acid, then comes HCl, then comes acetic acid, and the last one is HCN. Okay, so if this is a strong acid, I minus will be the weak base, And since it is a weak acid, Cn minus ion will be the strong conjugate base. And they have asked the strongest one, and hence I'll go with option number 3. 95, option number 3 is the right answer. Okay. 96. All the following carbocations are stabilized by resonance except lone pair, adjacent to positive resonance, carbocation alternate to pi bond resonance, carbocation alternate to pi bond. Okay, sorry, this is wrong. This double bond will go over here. Okay, let me just rewrite this thing. I have shown the wrong direction. This pi bond should go over here. Okay, this pi bond should go over here. Over here, pi alternate carbocation. This should be the right answer. So question number 96. 94 is not stabilized by resonance, it is stabilized by hyperconjugation. Okay. Next statement. This free radical or this benzyl free radical exhibit hyperconjugation. Wrong. Why? Because this is an sp2 hybridized alpha carbon. So alpha carbon is what? sp2 hybridized. Okay, this alpha carbon, it should be written as alpha carbon is what? sp2 hybridized. This we don't require. What we require is alpha carbon has to be sp3. So it does not show hyperconjugation. Hyperconjugation is also called no bond resonance true. So statement 1 is incorrect, statement 2 is correct. So statement 1 is incorrect, statement 2 is correct. Right option will be option number 3. Okay. 98. Among the following benzene derivatives has maximum number of hyperconjugated hydrogen atom. CH2 can be, C2H5 can be written as CH2CH3. Right. So this is your alpha carbon. And how many alpha hydrogen? 2 alpha hydrogen. So what will be the answer over here? So there are 2 alpha hydrogen, that means 2 hyperconjugating structure. Number of hyperconjugated, there are only 2 alpha hydrogen. Over here, this is alpha carbon, so it has 3 alpha hydrogen over here. Over here, it can be written as CH, CH3, CH3. Again, this is alpha carbon with respect to benzene, double bond. So it has only 1 alpha hydrogen. Over here, it is C, CH3, CH3, CH3. This is your alpha carbon atom with respect to benzene, right? And it has 0 alpha hydrogen. And hence option 2 is the right answer. Remember guys, okay, please make a note of it. Benzene. I know most of you have marked option 4. Somewhat I know that you must have marked option number 4. If not, then you have done the right thing. See, with respect to benzene, this is the pi orbital or loosely bonded pi electron cloud, and this is your alpha carbon. This is your alpha carbon. Please make a note of it. So this carbon will show you hyperconjugation. This will not show you hyperconjugation because this is nowhere related to, or that is nowhere bonded to a MTP orbital or pi loosely bonded pi electron or a carbocation. This carbon is bonded over here. Please make a note of it. So I'll highlight all the carbon atoms over here. Okay, I'll highlight all the alpha carbon atoms over here for your sophistication. Okay, this is the carbon which is what? Alpha. Again, this is your alpha carbon atom over here. This is your alpha carbon atom over here, and this is the alpha carbon atom over here. Now count the hydrogen. It has 2. That what I have marked, 2 alpha hydrogen over here. It has 3. So that what I have marked over here. It does not have anything, no hydrogen. So 0 alpha hydrogen over here. And this has only 1. So 1 alpha hydrogen over here. Okay. And that is the reason why option number 2 is the right answer. So please make a note of it, guys. Please make a note of it. Talking about question number 99. Which one of the following species has pi-pi conjugation and also exhibits hyperconjugation? First of all, what is pi-pi conjugation? Is it pi-pi conjugation? No. Pi-pi conjugation? No. Pi-pi conjugation? Yes. All of this? No. Does it has hyperconjugation? Yes. This is an sp3 or sp2 hybridized carbon atom. This is an alpha carbon which is sp3 hybridized. That means it has 2 alpha hydrogen. And since it has 2 alpha hydrogen, it can show hyperconjugation and pi-pi conjugation both. So option number 3 is the right answer. Got it? 100. Which of the following neither exhibit resonance nor exhibit hyperconjugation? Pen 2 in. Let us draw pen 2 in. CH3, CH, double bond, CH, CH2, CH, 1, 2, 3, 4, 5, CH. This is pen 2 in. Pi bond, alpha carbon, alpha carbon, alpha hydrogen, alpha hydrogen. So it shows hyperconjugation, but it should not show resonance. Although what has been asked is which neither exhibit resonance nor hyperconjugation. Since it exhibits hyperconjugation, we cannot take this thing as answer. Okay, so 1,3 butadiene, so CH2 double bond CH, CH double bond CH2. It does not show hyperconjugation, but it does show resonance. So this should not be the right answer. Ethene, CH2 double bond CH2, no hyperconjugation, no resonance, and hence that will be the right answer. 1,3 hexadiene can show CH2 CH, CH double bond CH, CH2 CH3. It shows resonance as well as hyperconjugation. See, with respect to this is alpha carbon atom, hence hyperconjugation, and with respect to this, resonance. Okay, clear? So this should not be the right answer. Hence the right answer is what? Option number 3. 100. Option number 3 is the right answer. Okay, so that was all the 50 question, guys, that you have encountered on your this test, MPL chemistry. And I hope that, guys, I have given you a fair enough idea of why the particular option is right and why other options are wrong. With this thing, guys, keep studying. We'll definitely meet again for another MPL chemistry paper. Till then, guys, thank you so very much for seeing this solution. God bless you all. Take care. Keep smiling.